Hello and welcome, everyone. This is Engineer the Agent Quality Flywheel. Earlier this week, you might have heard about Gemini Enterprise Agent Platform with four pillars: build, scale, optimize, and govern. Today, in this talk, we will go deeper specifically into the optimize. And we want to talk to you about approaching quality today as engineering discipline to help you turn your agents that pass evals into agents that do well in production. Quick show of hands, if for those of you who shipped an agent that passed evals, but then when you put it in front of your users, broke in production in a week. All right, I see. Good, you're in the right room. So I'm Dima. I work on Google Agent Platform, and here with me is my colleague Alex and our customer Daniel from Geotab. You will hear from each of us shortly. OK, so back to the question. I've asked it because I lived it. A couple of years ago, my team shipped a GCP infrastructure troubleshooter. GKE pod crash loops, nailed it. Load balancer misconfigurations, got them just right. Every eval we threw at it passed. And we were actually feeling pretty good about ourselves. But then we put it in front of users, and they quickly helped us find issues that we haven't tested. Cascading failures, for example, a database going slow, causing authorization timeout, and then 3 other downstream services failing. So our agent analyzed each incident correctly in isolation, but missed the fact that they were all a part of the same incident. Confident, wrong answer to users. And our evals in the end tested components, but failed to our production tested the intersection. If you think about it for a moment, this is actually one of the scariest failures for your agent. It's not when it breaks and you can quickly fix that error. It's when it looks like it's working, but your users aren't coming back. So quality is hard enough to get right with one agent. But when you obviously cannot test what you haven't thought to test. But when you zoom out and look at it across the organization, you are likely dealing with multiple teams, many different agents, different inconsistent quality bars, different levels of expertise. And of course, there is also the landscape that is moving around us, and it wouldn't sit still. Skills, harnesses, multi-agent system, long-running agents. Some of the tooling that we built today might be obsolete next quarter. From this perspective, we cannot really solve quality with a static evaluation suite, and we want to approach it as a continuous engineering discipline. So we think of it as a 3 phases, 1 continuous cycle flywheel. You might have seen variations of this within the industry, of course. Build and test, ship and monitor, and then learn and refine. Each cycle here makes the next one better. That's why it's flywheel, not just a process. And today we'll talk about Google's opinionated take on this flywheel, which is wired into our agent platform and is powered by the autorator stack that we developed alongside Google DeepMind. We would like to think of it as a durable engineering methodology where underlying principles that we talk about today still hold, regardless of which tools you use or how the industry looks like next quarter. Quick walk through every phase here. Build and test is your high-velocity iteration before you deploy. This is where you get to simulate diverse users to ensure good coverage. Then you grade full conversations with rubric-based autorator metrics. Then you cluster failures and optimize against the worst buckets. And you will see all 4 of these in demos today. Then when you ship and monitor your agent, your production really tells you what your evals couldn't. Tracing here is the foundational plumbing that powers the rest of the quality flywheel. It gives you visibility into every action, tool call, reasoning step. Then you use same metrics that you used offline to grade your live traffic. And in addition to ensuring that your agent is technically accurate, you want to look at usage signals to confirm that your agent delivers real value to your users. And then finally, learn and refine closes the loop. This is where your production failures become your test cases. Again, you cluster issues, you fix the worst ones, and validate and repeat. And each cycle continues to compound. So for the rest of our talk today, you will hear 3 perspectives from us. Daniel will talk about what breaks at enterprise scale. Alex will show you core concepts of eval, human-driven quality flywheel that you can start today. And I'll come back and talk about the agent-assisted approach and briefly about where we're headed. With that, please welcome Daniel to the stage.
Thank you. So I'm Daniel. I'm from Geotab. If you haven't heard of Geotab before, we're a fleet telematics company with over 50,000 customers and over 6 million active vehicle subscriptions. On any given day, we have vehicles driving on nearly every single road in North America. This is a map of coverage from 3 days of driving data from our connected vehicles. And across much of the rest of the world, it looks similar. So we process around 75 billion data points every single day, which is about 30 terabytes of daily data processing, which is a lot of data for driving AI insights. So we're investing very heavily into agentic experiences, both for internal tooling and for our customers, with hundreds of agents now running across the organization. So our SaaS platform does meet our customers' operational needs, but large-scale analytics via API, as many of you probably know, can be very cumbersome or impossible, especially for agentic systems. So analytics at our scale requires very beefy OLAP systems like BigQuery, which we leverage quite heavily. And most of our customers, though, can't easily interface with BigQuery. So one of the first things that we did, which we started 3 years ago when AI was emerging, was building a natural language to SQL engine. The idea is to attempt to execute user intent from natural language and get them the insights that they need faster. So early versions of this were pretty tightly scoped. We had pre-seeded example questions from internal domain experts and a very narrow set of schemas. Customers didn't tend to stray too much from this in the early days. It was pretty novel. They kind of just went along with the flow of how we were guiding them through the agentic application. So at that point, measuring success was very straightforward. It's very easy to do evals in a structured database system. We could just pattern match user inputs semantically and look at the execution accuracy against ground truth sets that we curated ourselves. So we were pretty happy with our evals. We kept releasing. Things were going well for a while. Our customers were saying, hey, this is great. My time to insight is decreasing. And then one morning, I open our feedback logs, and I see this real piece of customer feedback. Real feedback in our logs. So your developers are terrible, and you are useless. So very helpful. Thank you. I will action that right away. So very quickly, we went from our customers being happy to seeing this in the logs. So a lot of you have probably had evals that looked great, and then you saw some pretty terrible situations happen in production, as Dima was saying. So what happened here? In this particular case, after we went through the logs, the way the user had phrased their particular question, the agent used a very high-fidelity GPS table, which was meant for precision analytics. Great table, very useful. It's useful for a lot of things. It was not fit for the purpose that the user was asking the question. For the number of vehicles this user had, the system crashed. Okay, that's going to happen. In this case, instead of correcting, the agent decided to double down, thought it was right. It kept trying to optimize and fail, and the user experience pretty rapidly degraded. This was a very important customer. This is not the experience that we wanted them to have. So we as SMEs crafting the system, when we were testing, we would have never phrased the question to get the insights that the customer was looking for in the way that the customer did. So this just never came up in our curated set of test examples that we used for those evaluations. We just didn't think to test the system that way, the way the users did. So how do we miss that? The initial releases were very successful and very straightforward, but success breeds more work, right? The scope expanded pretty quickly. Customers wanted more questions answered, which meant new data sets, more complex multi-step processes, new features such as documentation retrieval, support subagents baked in, et cetera, and all of these multi-agent systems talking to each other with broader use cases, right? When you have that complexity, evals very quickly become much more complicated with a lot of subsystems to test and their interactions to test. So we were very quickly pushing out features much faster than our ability to craft evals for them. And many new edge cases started cropping up as the ambiguity of user intent increased. So with so many things users can do, it becomes really hard to test all the possible pathways through the multi-agent graph. So here was our evaluation journey to fix that. For just one agent, it's a long process, right? So starting on the left there on the red, we started with a fairly simple curated set of ground truth examples. So in a natural language to SQL pipeline, right, you can just eval execution accuracy. It's dead simple. But as we saw, that doesn't last for long, right? So onto the blue. One of the first things we noticed is that the LLM would come up with creative solutions or different interpretations to our test questions. And they were just novel ways of interpreting something that the user might have actually intended, but we just didn't think of. We didn't want to penalize a novel approach to a problem. So we then introduced LLM-judges tuned to human preference data. So this alignment process itself takes a while, but it's quite effective. So LLM-judges were great. They bought us a little bit more time. Onto the green. we're still getting customers complaining about issues in production. OK, so we add more direct feedback in the application. The team starts meeting weekly with the PMs to go through every single failure mode, creating individual tickets for our data scientists to steer the system. That's great. But we pretty quickly realized that obviously doesn't scale. There's just way too much volume of feedback that we were getting. So onto the yellow, we started building semantic embedding-based clustering pipelines to start grouping the failure modes into common themes. So look at areas where we got negative feedback, do semantic embedding of user questions and some of the trace data, group it into common failure modes, find the most high priority or high value ones, and start knocking those off one by one. Don't worry about the individual logs anymore. So that's great. That helped us for a bit. But of course, it's all after the fact. What we want to do is find bugs before our customers do. So thinking back to our disgruntled user who said that our developers are all terrible, what was the problem there? We just didn't understand the way that the users would phrase and interact with the system. And we're not them. We don't have their life and business experiences, right? So what we did was use synthetic data generation from crafted user personas to optimize and fine-tune the system before we release it. So we can act as these users and try to predict how the system is going to behave and fine-tune it for the different ways that they ask questions, not how our experts ask those questions. So that's where we are today for one agent, right? And it works pretty well, but it's a lot of infrastructure overhead and maintenance. A lot of our dev time now goes into those evaluation pipelines. So you can get pretty far now with smart prompt engineering, tool definitions, et cetera. That's going to really quickly get you to 80% performance. But that last 20% is really hard and is a systems engineering problem. So the problem is that 20% tax will very, very quickly consume more and more of your developer time, which is what we're seeing now in production. So it's no longer just one eval loop, right, for your one simple agent. Every single sub-agent, routing decision, retrieval step, tool call, et cetera, all need their own evals. So internally, we're seeing that just running the evals in our CI/CD pipelines consumes more and more time and tokens. So actually now, all of our evals consume way more tokens than our production system does from our customers. So our data scientists are constantly tweaking and tuning evals, spending a lot of time on that. Our developers are trying to optimize the runtime. Our runners are going down. The ICs now are starting to avoid doing evals or try to work around them just to get through the MR process faster and close their tickets. That's not where we want to be either. So it really quickly became a people problem and a process problem as much as a technical one, and it's really hard to scale across the org. So speaking of scale, right, as the agent tooling matured over the past year, we saw really rapidly increased AI adoption across the org. So the vast majority of our token consumption and spend now is internal agents and eval pipelines and not customer-facing products, which I found quite interesting. And now with things like Agent Builder, ADK, et cetera, both technical and non-technical teams in the org can really quickly put together agents and push them into production, which is really great. That's really empowering for them. But our core AI team just cannot keep up with the demand for evaluations across all of these teams. It's even hard to scale across just a few, let alone the entire company. So we've tried to democratize some of our tooling, but not all teams have the technical maturity, and the agent development is just really rapidly outpacing our ability to build the infrastructure to evaluate, optimize, and deploy it. So at this point, every team in our company, technical and otherwise, is now using agents. We have a lot of customer-facing ones, but literally hundreds of internal agents doing everything from marketing campaigns to anomaly detection to reading and parsing and optimizing how you respond to emails, just all over the company. And likely many of you in the room are in the same boat. If not, you probably will be soon. So in my opinion, the time to just handcraft perfect evals with expert data scientists is over. It just can't scale fast enough. My suggestion, save their time for only the most critical or tricky components or subcomponents, and leverage distributed tooling as much as possible. You need to use LLMs as autorators, judges, and have synthetic test generators to stay ahead of your customers. You don't want to find the failures after your systems are in production. Now, you do have to move fast, and you do have to get these agents into production, or your business will fall behind. But the evals part is still really, really critical. These production mistakes, especially the user-facing ones, are going to very quickly erode trust, and you don't want to see the feedback that I had in your customer logs. I'm going to pass it off now.
Thanks, Daniel. Hopefully you got a good glimpse into what it takes to build an eval system and the importance of eval systems. Those of you who already built them, maybe you don't want to maintain those systems. If you don't have one, then today I'm going to talk to you about what you can use in Gemini Enterprise Agent Platform. So first off, there's many ways to define evals, but at the end of the day, what evals is computing metrics over some trace or a session, some kind of representation of what your agent has done. When it comes to production, you do this continuously. You have some kind of input into your agent from a user. That can be a human or maybe another agent. And then that has to produce some kind of record of what occurred in between that agent and the user. And then you have a grader that goes over that record and tries to analyze it, tries to compute some metric that then you can aggregate. In batch evals, it's pretty much the same thing, except we don't have a user, so we need some kind of proxy for this. We usually call this an eval case. Sometimes you hear people calling it a test as well. And then besides that, it's pretty much the same pipeline. It goes into an agent and then produce a trace, and you score it with a metric. So Flywheel can be looked at it this way. You go into production, you have some kind of trace that then informs what your cases should be. Your production changes, the agent may have new features, your users change, maybe they discover new patterns or they have demands that are growing. The world may be changing. Maybe now whatever your agent has been doing is no longer relevant. So your cases need to be continuously updated. Ideally, you'd be looking for your production logs, maybe filtering them through some metrics, and then using that to inform what your new eval set should be for your next iteration of the agent. With that, let's look at how you can do a lot of this with the enterprise platform today. So first off, setting up eval monitors. This is actually the easiest thing you can do. It's very, very simple. You'll go to the evals tab, and then you click new monitor, and then you'll see the wizard like here. There's only 3 things you need to know about this wizard: how to filter traces. So we give you a control so that you don't have to analyze every single trace within eval metrics. For example, you can only pick traces that have high token count, or maybe that took very long. And then there is setting up metrics. There is a lot of pre-built metrics that I'll go over in just a minute. Or you can set up custom metrics. It can be something you write in code or LLM-as-a-judge. It's really up to you, and we highly encourage you to use a mix of metrics to make sure that you properly monitor what you're trying to accomplish there. And then lastly, sampling. So sampling is there to control for cost. If you have a popular agent, you probably don't want to monitor and evaluate every single one of your traces. If you have a not so popular agent, maybe you can go ahead with 100%. We give you a control, use it or lose it. And once you set up the monitor, you get up dashboards. You get all these metrics that you've been computing. You can see them in various different views. We give you pre-built dashboards. You can also customize them. There is a fantastic underlying query engine that allows you to build custom dashboards if you want to. And the other thing that comes with dashboards is alerts. So if you want to set up a particular policy, for example, my agent has drifted a percentage from what the typical behavior is for a metric, you can get an email or a Slack message or a pub sub and then dispatch a team to investigate and act accordingly. So when it comes to batch evals, it's a little more complex because when you analyze evals locally, you don't have a production system. So you have actually quite a few new components that you need to be aware of. There is the core infrastructure, of course, managing data sets. This is your typical kind of CRUD of data sets, metrics, cases. You also need to have some analytics to analyze patterns across different eval data sets. And then there is actual execution details. Namely, you need a case generator. Every single agent starts without any trace, so you do need to seed some examples of what this agent should be doing and analyzing. Case generator needs to be aware of what the agent does. It also needs to produce something that is not duplicative. A lot of one-shot examples with models would just give you almost the same cookie-cutter test that is probably not well-suited for your agent. Then, because we don't have a user in local, you need a simulator. You need something that actually emulates the answers of an actual user to the agent. Majority of agent interactions today do require some kind of user input. They're multi-step. So unless a developer wants to act as a user for all hundreds of likely there are hundreds of test cases, they need something that pretends to be a user. And we give you plenty of controls in that simulator. You can set up different user personas. You can set up specific conversation plans to make sure that you're emulating exactly the scenario that you expect to see in production. And then there is environment emulation. So when you're testing locally, in many cases, you don't want to call your production systems. Sometimes those systems are not available. Maybe you don't want to pollute your prod database. Or maybe some of your tools are sensitive. You don't want to call a credit card billing transaction every time you test an agent. So you need some kind of emulator for this. We give you an environment emulator that allows you to mimic errors, mimic latency, mimic specific tool responses, and various other environment behaviors that would be easy for you to run locally. And the most important part of evals is metrics. At a high level, there is really 3 types of metrics that are widely used in the industry today. There is code, which is not really that different from software testing. You define some kind of test with the code, and then the output is what you use in aggregate. Then there is a new kid on the block with LLM-as-a-judge. This is something that only started to occur with generative models appearing. Typically, you define one prompt that you apply to all outputs, and this prompt has some kind of score criteria. One downside of this approach is that because you need to apply the same prompt across many different outputs of an agent, you tend to have a very complex prompt. Because if your agent does, let's say, booking trips and maybe answering some questions about destinations, now you need to have a prompt that makes sure that allows you to grade both of them. And that ends up with a lot of if statements inside of the prompt, which we've seen, or just very complex prompts that end up being not that useful in the end. And then there is the newer thing, which actually does not have an accepted name. We call them adaptive rubrics or adaptive metrics. This is when your metrics are generated on the spot. So you first generate the metric for a particular input of the agent, and then based on this, you would grade this metric on the output. This is how it works in practice. So you have kind of a 2-step process, a generator and a validator. A generator for rubrics would be, for example, I give here an example of a business trip booking agent. And a user would ask to schedule a meeting about a particular topic. And then it would also say, like, hey, I actually want the meeting to be not 30 minutes, but 45 minutes. Pretty typical, fairly easy conversation. Given all this, the rubrics generator would then generate a set of rubrics to evaluate the output of that interaction on. You can see that the rubrics are actually pretty specific to this conversation. For example, one of the rubrics is asking whether duration is exactly 45 minutes. Another one is asking about the start time at 3 p.m. But the other rubrics might be fairly generic, because for a majority of the interactions, you want to test if the agent called the right tool, if it did the right input into that tool, and so forth. So that was the generation process. And then there is the validation process, where each of those rubrics you apply on the actual trace, the output of the agent, and then you get some kind of score or pass-fail, and then you aggregate this into a metric. This process is a lot more robust, especially if you have an agent that's doing a diverse set of things, because it does not require you to have a ground truth, nor does it require you to have a very complex prompt that tries to if-else for all the different scenarios that the agent is doing. We give you a set of those rubrics out of the box. The main advantage of those rubrics, besides them being fantastic at evaluating your agent, is that they're managed by us, and we've actually calibrated them across many different use cases in Google and DeepMind. All these rubrics were basically confirmed with human annotators to have a very high correlation with what the actual humans would have produced as the outputs. We'll give you 7 of those. A couple of them are new today. So final response quality looks at the overall style of the conversation, things like relevance, truthfulness. Then there is tool use quality that analyzes how well the agent is calling the tools, if it's using the outputs correctly. Trajectory quality, pretty standard, seeing if the sequence of actions the agent took is well done. And then their task success, probably the most popular metric, just seeing if the agent actually accomplished the task that the user was asking it to accomplish. And then hallucination and safety are the metrics that we've had for a while for our model evals as well. Hallucination looks whether responses contain some speculations, basically something that was not as part in the trace. And then safety is a check against various guidelines that we have for safety and harm. With that, let's move into some demos. All of these functionality is actually available to you through the SDK, API, and UI as well, and also a skill, which we'll talk about in a little bit. I'll show the UI. It's the easiest to show. It's easiest to understand. So first off, cases generator. So when you start your eval, you'll have an option to select a session simulator or cases generator as well. With that, in here, you can specify your agent's description. You can kind of steer what you want to generate, which areas you want to cover for your agent in your cases. And obviously, you can specify the number of cases to generate. Then you'll see the actual cases being generated. You can preview them. You can understand if that actually complies with what you thought you want to see in production. Also, notice here that we have a conversation plan column. That's the user simulator in play. So conversation plan is basically what the simulated user would be doing for this conversation. You can edit this freely. You can copy paste from maybe some other examples that you have. We have a lot of other functionalities in simulation, like defining specific user personas and specific conversation, mining traces for conversations. But for now, we give you a fairly simple interface to get started where you can see exactly the plan and edit this. And then when you start, you get into the evals worksheet, which is the main work area. So here, each of the rows is the case, like one eval case, and then each of the columns would be a metric. And we give you nice tools here to add additional metrics. If you want to see some examples, you can add cases, you can evaluate multiple agents at the same time, and filter group columns, kind of like an Excel spreadsheet, or Sheets spreadsheet, I should say, for analysis of your eval data. Once you click on any of the examples, we'll give you a full breakdown. This is pretty much the same rubrics that I was showing in my example, except these are actual rubrics that we had on one of the agent sessions. You see here that you're given the rubric score, and then the reason for us assigning this particular score to the rubric, and also a lot of metadata metrics like the total duration of the session, number of traces, and so forth. And then lastly, if you have a large eval data set, then typically you want to cluster it. You don't want to review every single issue individually. You want to see kind of some patterns or some high-level answers, and like what is wrong with my overall agent's behavior. And this is where clustering comes in. We automatically cluster things using a taxonomy that we've pre-built. And again, it's been tuned to human evaluators. You can also have your own taxonomy if you care about particular areas of behavior or areas of cases. It's pretty easy to add a taxonomy into the system, and then we'll be grouping the issues based on how you want them to be grouped. So that's when it comes to batch evaluations. And the last step in evals is typically optimization. So I got some scores in my evals, like how do I actually make those scores better? And again, end of the day, optimization is running evals across different versions of an agent and comparing them to make the agent better. So it's pretty much the same loop that I've showed you with the evaluations. You have some set of cases. They go into an agent to produce traces. Then you score them. And then you have some optimizer, kind of a new step, that takes the eval results and then tries to create a new version of an agent that would hopefully work better on the next run of the eval data set. We don't have a UI for optimization today because we think that it's much easier to use optimization as a skill right where you develop the agent. And that's what Dima is going to talk to you about in just a minute.
All right. Thank you, Alex. So Alex showed you what a human in the loop looks like, where you work through the steps yourself. I will talk a little bit more about a human on the loop approach, where you work with your coding agent that will drive some of this flywheel for you. One quick disclaimer for the skill that Alex mentioned. This is really, really hot off the press. It's based on our early access program that we just ran over the past few weeks. Thank you to those of you, by the way, who provided feedback. And for those of you who haven't been a part of it but would like to participate in the future ones, please feel free to reach out to your account team. We are more than happy to work with you and get your feedback and bake it into the next iteration of the platform. Now, what I have here is a very simple agent. It has a system prompt and 5 tools. It's a support chat agent. Essentially takes in a customer problem, investigates it, tries to help. If it cannot resolve it on its own, we'll go and escalate to a relevant human expert team. The problem that we have here is that there's no evals, there's no test data, no production traces. We essentially are starting cold. This is where we usually begin. Those of you who built a new agent from scratch, you should be very, very familiar with this. So let's go and point our skill at it. So skill, our quality flywheel methodology has a runnable implementation. Has same name intentionally. It comes with a 5-step guided workflow covering key phases like data synthesis, metric selection, and analysis of the results. It also ships with a failure pattern library, which includes root causes and fixes clustered per class of metric. And it also includes even typical configuration errors to help you get through an end-to-end evaluation pipeline setup very quickly. So snippet on the right here shows a low score on the tool use quality metric, typically caused by ambiguous tool descriptions, overlapping tools, incomplete schemas, and so forth. And some of the remediations here could be making your tool descriptions more precise, adding constraints. And you can think about this as an encoded expertise in a markdown file or set of files in case of this skill. It's open, posted on GitHub. We'll have a link for you to get started later in the talk. It's extensible. Over time, we will extend it with our expertise, and you can, of course, always include your own. In order to use it, you can install this in any coding agent today, Claude Code, Anti-Gravity, any of them. I personally use Anti-Gravity since I'm from Google. This is an example from my own testing. So what's happening here, I gave my coding agent, Anti-Gravity in this case, 4 sentences in. And using this skill, it came back with a structured proposal. There's no eval data. It just reads system information, system instructions that I have, my agent definition essentially, and tools. And it comes back with a few key points here and some numbers worth considering. For example, it suggests that we should start with 50 multi-turn scenarios here. And all of those simulation instructions that you saw Alex demonstrate also are coming from agent description. It's a great starting point. Also comes with up to 10 turns per scenario, which is an important number to review. In this particular case, 10 seems like a reasonable starting point for a support agent. But this is, of course, something that you could adjust based on your actual usage over time. General idea here is we would like to start small. Have at least some eval end-to-end, and then we can increase that coverage as we test our agent ourselves and then learn what breaks in production as well. Another important part here, Skill also picked metrics which match my agent's shape. In this case, it's multi-turn trajectory quality and multi-turn task success, which seems like a very relevant and great starting point for this particular type of agent. Now, after those 4 sentences in and a bit of a back and forth on the planning side, we get a coding agent generates a full entire pipeline, which includes SDK orchestration, data set creation, metric selection, execution, scoring, and results analysis. So it writes the code, runs it, and next it matches those results against the pattern library for structured diagnosis. So I'll walk you through, these are example findings on this particular agent. I'll walk you through the one in the upper left. User here says, hey, my instance is down. The agent assumes compute engine, goes and investigates that for 3 turns, gives the user a very confident but wrong troubleshooting path, only to get corrected by the user that, no, this is my Cloud SQL instance that I'm talking about. The suggested fix in this case is correction to the tool schema, adding an enum, compute engine, Cloud SQL, Spanner, BigQuery, et cetera, to force an explicit commitment by the agent before it begins investigating. The other 3 examples here touch on different other points in the stack: prompt, configuration, architecture, new tool definitions, et cetera. One question that is worth considering in this context is, could a frontier model like a Gemini 3-class model figure this out? Probably, given enough time and budget, it would. We think of this pattern library more as a shortcut to help narrow the initial exploration and help you get to results faster and cheaper. But it is just cherry on top of the cake. The actual cake here is the ability to quickly bootstrap your eval end-to-end and do it safely where your evaluator is decoupled from the optimizer. These are some example numbers here. After I have approved fixes, had my coding agent go through a few loops and implement and rerun the evals, you get to a validated delta. And this is your first cycle complete. Again, key insight here is that the skill helps you decouple your optimizer, in this case, your coding agent, from what measures it. In this case, it's our eval service. All 4 metrics, or however many metrics you have, will be tracked simultaneously. So in this case, if routing is up, but escalation is down, you would catch that immediately. This way, we keep the eval honest and prevent the optimizer from gaming the system. Now, what you saw just now was a skill-assisted optimization loop. This is where model reasons broadly about your agent across the entire stack. So you prompts, tools, architecture, configuration. Skill can help you get to that 80% that Daniel talked about faster and in a more systematic fashion. Really great for the first pass, fast iteration. In addition to this skill, we also recently added to ADK Optimize. This is an extensible framework that is meant for more offline and targeted optimization. We ship it with JEPA for prompt optimization as a starting point. But the framework itself is generic. It takes an eval pipeline, it can be custom, takes your agent in, and provides you with an improved revision of that agent. So you can plug in any optimizer. And over time, we would, as we figure out what works best, we will extend this library with additional algorithms. So skill for breadth, optimizer for depth, you can use both today. There's one more flavor that is not really shown on this slide, which is a fully autonomous auto-research style loop, where your optimizer will pick a worst cluster, failure cluster, then hypothesize about how to fix it, implement the fix, test it, keep the fix or revert it, and do this many times over, like what Alex had in this slide with the optimization multiple iterations. We are actively thinking about how to expose such capabilities as a part of our platform, which brings me to where we're headed. As agents are getting increasingly more and more complex, you probably are already dealing with multi-model, multi-agent, long-running agents. We want to make sure that eval, of course, keeps up with that. Skill compositions is one interesting area where we are looking into how to effectively evaluate individual skills and their combinations as well. Then there's, on the improvement side, there's autonomous hill climbing, another active research and development area from our perspective, alongside with guardrails and interpretability for us human users who are looking over that fully optimized loop. And on the ship bucket, I would highlight the quality gates as a CI/CD checks. We also are thinking about a Sentinel agent, which is essentially an in-prod sidecar that would be mining your traces and trying to detect and help you pre-diagnose issues. And then there's the overall production versus offline fidelity, which Alex had on his slide with production looping back into the local eval. So these are some of the highlights of where we're investing. To bring it all together, you saw Daniel talk about the enterprise quality challenges. Alex showed you how to set a full eval pipeline, including production monitoring. And I touched on the coding agent, how it can help you spin the flywheel, diagnose, fix, validate, repeat. One thing I want to call out here is that models keep getting more capable very quickly. But so does the surface area of things that can go wrong. And from that perspective, the smart optimizer without an independent evaluation could be a really smarter way of gaming yourself. And quality flywheel in this context is a durable methodology that will get more important over time, not less. So when you are back in front of your computer, you don't need to run the whole quality flywheel on the day one. You can start really small. Set up that evaluation monitor. It takes literally 3 minutes, and you get a better production signal on your agent quality. Then you can keep going and run some full trajectory evals on your existing traces. Another 5 minutes or so, you get a better baseline. Then you can also go and create synthetic data, synthetic cases for gaps in your test suite. That could take 15 minutes maybe to get started and write up a few personas, gets you better coverage. And maybe you can also go and kick off that ATK optimize run and go grab lunch while it works for you. And then you come back to an improved system prompt diff that you can review in 30 minutes. And this way, maybe after lunch, you get the full flywheel end-to-end running. One parting thought, I had a really great conversation with a customer yesterday about hammers and puppies. Traditional enterprise software is like a hammer. You engineer it, you ship it, it works, you patch it regularly, deal with bugs. Agents are more like a puppy. They need continuous feedback, they need training, attention to get better over time. Aaron, if you are here in the audience, thank you for that one, and we should do a talk together about it at Next. So your agent doesn't really need to be perfect. It has to be improvable. So we encourage you to use this flywheel, ship, measure, improve, start turning it. These are the QR codes. They give you links to all the relevant docs, and including the skill. It's a GitHub link. You can go and download it and get started with it today.